project of Icon, a project with targeted of the verifying the net zero energy building with air source heat pumps, not only by the simulation but also by the real measurements. And the presentation consists of three parts. As you know, the first one is the background by the why the Icon is starting the net zero building projects, and the second one I will explain the concept of our test building and the technologies we installed. And the last one, the most important point is also the presentation will show you the final results. It is important to mention that we actually measured the yearly consumption in a real building, and it will not only show you the calculations. We will start the background. Making the new regulation for the future Europe always take its 2020 targets in mind. It means 20% less CO2 emissions and 20% less primary energy usage, and increase renewable energy share 20% too. Also, the Icon tries to do that, and therefore the Environment Research Center was established in company. The department that will follow the legislation and spot new tendencies and turn them into the new appliance, always keeping the environmental conscience in mind. This is important because of work, because of we look to the total energy pie of Europe. We can see that the more than 20% of the energy is going towards the buildings. Of this 20%, sure, 80% is related HVAC sector. So they can take responsibility also in this part. The previous slide showed the importance of the building sector. Therefore, European legislation makers are also trying to improve these energy consumers. This is done by the EPPD legislation, Energy Performance of Building Directives. This directives tackles the energy performance of buildings, looking to new and retrofits, making certificates linked with the building permits, and in the final request of the EPPD, even the setting the target on nearly energy building. By the end of 2018, all public buildings have to be nearly zero energy, and by the end of the 2020, even all new buildings too. This leads to challenge, but also to opportunities for company. So we have to help to find the ways to do energy saving by delivering high performance equipments, which in the combination with the renewable energy generation can lead to zero energy building. This slide also you can see the trends in some of the European member states. We see them they're putting the targets of to reach the zero energy for the buildings. When we look at the second step, what we concept and installed technologies. We wanted the measurements in real operational office buildings. So this newly constructed office building in the Rath area in Germany was selected. It is an office for a small to medium enterprise connected to warehouse. The office consists of 2 stories, together 535 square meters. The warehouse part is the 800 square meters, but this is not also conditioned. In the bottom table, you can find the characteristic of the building shell. as you see, this is not extreme installation values. We wanted to prove that with a flexible building design and high efficiency products in nearly zero energy building is feasible. Take into account the German building standard is quite severe compared to other countries. The office part mainly consists of smaller individual offices. All rooms have temperature sensors, but 2 rooms, one on each floor, are even equipped with more sensors as CO2 sensors, humidity sensors, motion detection, light intensity, and etc. Here you can see the also picture from the inside of the building, and you can also see the column with the many sensors and the measurement temperature stratification elements. Then what we installed the system, the heating in done by 2 diagonal thermal low temperature air to water heat pumps. These are connected to floor heating system. For the cooling, we use the VRV air to air heat pump system. For ventilation, is provided by the warm heat recovery system, which is a sensible and latent heat recovery. The lighting is done by the LED technology wherever is possible. Because the building had to be net zero energy, so this equipment has to need it on site. And this is by done the thin field photovoltaic system of 27 kilowatt P. All these systems are connected to also energy monitoring system. Now, if you look at the year result, I can give you the also measurement results after that. This will include the energy flow overview, but also the comfort evaluation. To end, I'm going to give you the measurement of the photovoltaic field and also comparison with an alternative solution for these nearly zero energy buildings. At the first, measured results for the period February 2011 till March 2012. The different flows are sorted kind. You can see that heating and lighting are the 2 biggest consumer in this building. But the total amount of all this flow is compensated by the photovoltaic system installed on roof. The building was even 977 kilowatt-hour energy positive this year. What if we did not make use of heat pump technology? Then you have to look to H part. This is the energy demand. Due to the heat pump, COP, this can be reduced. If traditional solution like fossil fuel boilers would have been used, amount of the energy that needed to be compensated by the photovoltaic system would have been much bigger. In this graph, makes the split up per month. The green bars represented the energy production. This is mainly situated in the spring and summer period. The consumption mainly in the winter period also. The comparison between hatched and solid bars shows the difference between our simulation and the measured reality. Only two months have a considerable difference. Why? The March was the start of our measuring campaign. Not all settings were set optimally yet. This shows the importance of the commissionings also for us. In February, because the real weather condition different a lot of from the reference year in the simulation, minus 15 degrees Celsius measured, compared to our design condition, minus 8 degrees Celsius. Sure, we cannot judge the energy efficiency of a building without looking to comfort. Therefore, PMV measurement was done in the different rooms. This measurement has to be between minus 0.5 and plus 0.5 in the ideal comfort cases. You can see this is the case for the summer and winter period also. The measurement on the previous slide were done 2 particular days. So let us look to longer time span with the EN 15251 standard. This standard defines different temperature zones to express comfort. As the heating done with the underfloor heating controlled by valves per room, we measured 97% of the time comfort at normal level, expectation of even higher as 17%. For the cooling comfort evaluation, the principle is a bit more complicated. This time the users in the building have more control. They can individually decide whether they want to turn the cooling system in their room on and can select the desired room temperature. This is not necessarily the same as the desired temperature according to standard, so could lead the values outside of the criteria, and this shouldn't be interpreted as overheating. It will be illustrated in the next slide. As you see that the room 106 is 20% outside of the category. It means, is it the overheating? And therefore we can see that the low energy consumption? No. If you look at the temperature deviation in this room, we can see that the curve around the set point of the users, it means he has to put his set point quite low, what we expected, about 83% of the time, almost 22 degrees Celsius. It means much colder. The standard considers this is too cold, normally yes. The users think this is comfortable. Let us discuss the layout of energy generator on roof, the thin film photovoltaic system. This system is counting next to direct radiation, also on reflection of the roof surface. Therefore, the roof is made white, giving also the advantage of being a cool roof. One part of the roof was treated with the Dickensical white paint, the rest with traditional white roof coating. I will explain the effect, the roof temperature and the yield of the photovoltaic system. As you can see the picture on roof. In these slides, the principle of the photovoltaic system and the combination with the, our Zephyr paint, you can see the two effects. One is due to the increased reflectivity, the current and thus also the power of the photovoltaic system increased. And the characteristic of the Zeffel paint, the roof temperature is to 10 Kelvin lower than the standard white coating. This has next to reduce cool load and effect on the yield of the photovoltaic. It colder, the more benefit in power. The combined result of the measurement time you can see also in this slide. The field coated with the Zeffel paint produced 11% more energy than the field with the standard coating. I want to make a comparison between the heat pump concept for nearly zero energy building and the total different approach. From our IBP, a German research institute, proposed to make a comparison with a biomass fueled cogeneration unit. This unit can provide sufficient heat to do space heating and the generation of the domestic hot water also. At the same time, it produced electricity. In the summer period, operation time of this unit is prolonged by using the heat to start absorption process of an absorption chiller. To run the thermodynamic process optimally, a cooling tower is also added. Due to the fact the CHP also generates electricity for PC system to become NZEP can be similar 14 kilowatt P. Comparing the energy flows shows the difference between two solutions. Although CHP solution has more distribution and the storage losses than the heat pump system, the primary energy consumption of the heating is remarkably lower. The only reason can be found in the fact that biomass can be counted with a primary energy factor of 0.2 in Germany. The cooling energy, on the other hand, is in the alternative solution quite higher. This is due to much higher auxiliary energy demand, distribution of the cold fluid, recooling of the absorption chiller. The total picture shows that the final energy consumption is almost equal in both solutions. If we look at the investment cost, on the heating system side, cogeneration unit is more expensive than the air-to-water heat pump. So we can go to store. You have to also frozen storage and chimney. On the cooling side, investment for an absorption chiller will also be higher than a comparison system. As mentioned, the photovoltaic field of the alternative is remarkably smaller, so the investment cost will also decrease, leading a slightly cheaper investment cost of the total alternative. But if you take maintenance and running costs into account, you can also clearly see on the bottom graph that this is already paid back after 1 year. So from economic point of view, the heat pump concept is most competitive for nearly zero energy buildings. And finally, the conclusion parts, what we can say that the targeted by European Union government is very clear, and it gives some also directive to Commission. So as a company, Daikin wants to act also today. And net zero energy target reached in 11 and 12. And also comfort guaranteed during all years. And heat pumps are looking to KTOC technology for net zero energy buildings. Thank you for your attention. I think I a little bit past my time. Sorry.
Thank you. We have 5 minutes before our scheduled time, so we are fine. Thank you. Questions? I'll give you, if you could wait for the microphone and please identify yourself just for, no, just wait. Okay.
I am Joseph Virgon from Centre de Thermique de Lyon. I have a question. Do the system of heat pump you present is possible to use in existing building? And
Sure.
If the time of return back time is okay also?
Sure. This is heat pump system. Also, we call the VRV system, variable refrigerant volume system. Also, we installed in this building. This system also applicable for the existing building and for future buildings. Also, we are always design and installed the building. And our company also have some heat pump products for the oldest buildings. It was installed with the heat pump system with the some maybe we can say the old gases R22 or R410 407. It is also possible to change system with the new gases. It means this heat pump system with combined with the hot water system also is available to use for existing and the future building with the highest in order to get the high performance energy.
Hi, my name is Lawrence Chi. I'm really curious about the air source heat pump working in summertime, especially in where the climates are 30 degrees and above. What is it able to give you sufficient cooling indoors?
Sure, it is also advantageous for our company. In that climate, more than 45 degree above or nearly 50 degrees Celsius, we have also a kind of different products as a heat pump system. We called also a high ambience VRV system. It works nearly 52 degrees Celsius in that climate. It is also different products what we sold in Turkey or the Middle East area. But this is also possible to use this air to air or air to water heat pump system in that high ambience temperature climate regions.
I have one question for you. So the main assumption, in fact, in your demonstration is the guarantee of the COP of the heat pump. And you have quite high, it's about 5 as far as I've seen. Did you evaluate, how did you evaluate this annual COP and how do you guarantee it?
If you give the guaranteed for the application, heating and a cooling system, the main important point is the selection of the equipments. Sure, when we look at the heat pump system COP, average COP, as you know that everybody says that the 4.5. But you can also reach the highest COP, especially in the partial load. As you know that the 4 or 4.5 COP is normally 100% or fully load COP value. But this heat pump system, everybody knows that they not always working on the fully load. Average 65% till 80-85%. When we look at this efficiency of these systems, more than 4, nearly 6, 7. When we when we get the lower partial load, 25%. Some heat pump system, for example, water to water heat pump system or air to water heat pump system, can reach the 11 and also 12 COP values with the good design and the good selected equipment or correct selected equipments. But the average, yes, you are right, we can say the almost 4.5.
Okay, thank you. We are 1 minute away from our deadline. Any burning last question? No? Thank you very much then for your contribution.
Thank you very much.
Well, I hope you enjoyed the session. It was very interesting. I think we'll be discussing this nearly zero energy buildings issue till tomorrow. I will just give you a hint. What we see is a normal building with a very good envelope, optimized systems like this, and then we put a hat on the building with photovoltaics normally. This will be something that we should be thinking about and thinking if this is the, well, it's apparently will be the building of the future. So we'll have to discuss if we want that and how to deal with that. So I hope to discuss that with you tomorrow also. Thank you very much. Have a good lunch. We'll see you after lunch.
To everybody here, and then we will try to start this panel on NZEP concept and Mediterranean countries. Then we will organize the session this way. I will start introducing the item, and then the expert from different country will try to give information how their own country has faced such a problem, let's say, because sometimes it's really a problem to have a right definition to avoid later on practical problem when an HVAC engineer has to design or to certificate the energy performance of a building. Okay, if you can take my presentation, please. Okay, then as I said before, we have 5 experts from France: Francis Allard; Italy, Stefano Corniati; Portugal, Eduardo Maldonado; Spain, Pedro Quiles; Turkey, Zerrin Yilmaz, dealing with these topics. And I will try to give an overview of what is the background behind the definition of the nearly zero energy building. And we have to remember that we have the European Union from one side and the countries from the other side. And any action is a kind of balancing between what is the Union wishes, what each country is able to apply. Then, just to give an idea, we had already mentioned the APBD directive revised in 2010. It was asking for an improvement of energy performance of building and is giving exactly the units in which the energy performance has to be certified, has to be declared, which is kilowatt hour per square meter a year. Primary energy. But then there is a question we will see later: what kind of primary energy? Is a really huge point. And then is assessing that we have to reach the nearly zero energy building. There was another important directive which is in some way linked to the previous one, which is the Renewable Energy Directive 2009, asking for increase of renewables up to 20%, and saving of fuels and so on. And in this directive is written that buildings has to give their own part in these savings. What's inside the PPD recast? No, Article 9 is just recalling, let's say, the nearly zero energy building, which is defined in the definition, and it's saying that by December 31st, 2020, all new buildings have to be nearly zero energy building. And another important article we don't have to forget, 4 and 5, are settings of energy performance requirements are specifying that when each country is going to set the energy performance the new building or furnished building has to have, this limit has to be chosen on the basis of cost optimal levels. And we will see what does mean that. This means that when the requirements are set by each country, they have to take consideration the cost of the efficiency they ask for. And we can simplify with this equality. Remember that cost optimal for the directive application means the energy performance that leads to the lowest cost during the estimated economic life cycle. That means, for instance, 50 years, I suppose that my building is living, and then I have to perform the calculation taking consideration this lifetime, okay, with the total cost. It's the first time that economy and economicity is coming in. What does mean this? You can see here, this is a wish that we have a nice curve. We will see later that never we have such a nice curve. We have a global cost on the vertical axis and instead the primary energy consumption on the horizontal axis. And what we do, of course, if we have such a minimum, reducing the energy, primary energy consumption, we can have one point in which the cost of running the building in this way for its life will have the less energy consumption. But of course you can move right, and moving right the cost is going up, but of course you will use less primary energy. And when you fix this left position according to the minimum, this will be, on a national basis, probably the nearly zero energy building. That means it's not zero because the cost maybe will rise up too much. It's possible technically. The problem is how much does it cost? And then is a compromise between the optimum from the economical point of view, which should set the actual limit today, and the near future in which we assume that we can invest as a country some money to save energy and to reach such nearly zero energy building. Then the concept of the nearly zero energy building is connected to the cost optimality. It's not something you can define without. What you can define without is the zero energy building as a reference, as a limit from the technical point of view. Now, this is what we have in reality. The dot are calculated points, and you see there is a lot of spray. Then we have envelope curve, which are given this minimum, which is very flat. It's not just one point. You can see that there is not really a point. But what is more interesting, this is another point, you see that the yellow dot, in which we take in consideration technical system using PV, photovoltaic electrical energy from renewables, we can have negative primary energy use. Okay? And this is, in my opinion, is a real contradiction. We will understand later why. Because if primary energy is the energy of a source, that means I'm creating energy, okay? If I'm talking about primary energy. If I'm talking about energy, I'm making some conversion, or some exchange. But with primary is quite strange. Now, what's about the climate? We have a climate which is very different from North to South Europe. You can see a winter picture and a summer picture. You can see what's the difference we have between North and South. And the main point, of course, is that is a typical day, a year in a typical Mediterranean city. You can see that we have quite a balancing between cooling demand and heating demand. It's not only heating, okay? It is making some more complication in the definition of the nearly zero energy building. We have to take in consideration this. It's not just heating. Then the buildings are not in the southern of Europe, are not built as in the northern part of Europe. As I said before, the cooling demand is high as the heating demand. And then Mediterranean building has to be able to perform effectively, of course, both in winter than in summer. But till today, for instance, also in Italy, but I think in other Mediterranean country, we have the indicator for the energy performance only for the heating, not for the cooling. Okay? This is not, and I think because this trying to, then the people involved in the building construction try to optimize the building according to the indicator, that means only for the heating. And then maybe the result is to have a worse building for the cooling. Instead, the building has to be designed and optimized for the year round, the whole year round. And then, of course, as I said before, what we need is optimization of the building for both heating and cooling from the envelope side, and of course the heating and cooling technical system has to perform as in the best possible way, using as much as possible renewable energy. Then, how has to be defined an ENZEM building for satisfying all these requirements? Because we have such weather which is not exactly what we have in Northern Europe, and then there is a limit we have to calculate according to the cost effectiveness. Then the starting point is what I call the ENZEM paradigm. The characteristics of a nearly zero energy building are those of a building which must meet the following requirements. The first is the thermal energy needs reduced to the extent reasonably practicable. Insulation increase, etc. Each time you will see that we link the increase of performance to the possibility to realize. That means economically to realize, not technically. The energy requirements of the plants reduce as much as economically feasible. Heat recovery system, increase of the efficiency of the air conditioning system, and so on. Then, third, the energy requirement has to be covered as much as possible with the use of energy carriers from renewable energy source or produced on site by renewable energy source. This is one of the requirements is written in the directive. And of course, all this has to be obtained under the economic and financial sustainability. Because another way around, we can say we have already nearly zero energy building or zero energy building. But let me say that if you think about energy classification, are A+++ building. That means they cost twice normal building. But this has to be a limit by law. Then I cannot say that everyone has to spend as people like to have a Ferrari in their own hand. Okay? That's the main point. Now, the experts are going to present their own point of view on how Mediterranean countries have faced this problem, if any. Maybe for some countries it's not a problem. We will see, I don't know. And then I think we can start from Francis Allard to give his opinion on that, and then with the others. Thank you.
Thank you, Livio. So I will just give you the picture in France of what we are doing now. If I may have my presentation. Okay, thank you. So first of all, as most of our countries, France lost its best practice in building after the Second World War for 30 years, roughly speaking. And now we are trying to recover this deficit, in fact, by most of the time by regulation. So the concept of positive energy building or low energy building is not a really recent concept, but we have literature on this domain for a while. The main elements in France was a decision made in 2007 that we should have, in France, it was a political decision, not a technical one. So we should have all new building in 2020 should be more or less zero energy building. And then we tried to apply this, of course, and the first voluntary label was obtained at this time. It's a very strange thing in a country like France. We are a very Jacobean country. And in fact, this progress came from a bottom-up system with an NGO, which is F Energy, which published the first voluntary label to a low energy building in 2007. And it was extremely popular. So this label is already focusing on low energy building. So it's a 50 kilowatts primary energy per square meter per year for residential building, with a modulation of the climatic region of different parameters, but the general target is this one. And for renovation, also 80. We don't have to forget the renovation in our... and for non-residential, it was just an improvement with a reference basis, which was actual regulation. So in 2009, we launched what we call the Loi Grenelle. And so we proposed a new regulation, which is in fact taking the voluntary label and transform it in regulation, roughly speaking. So it was published at this time, and it's mandatory for all new buildings in France since last January. So I think it's maybe something we can discuss, because the first element of this regulation is to optimize the envelope of the building first. So we settle a new parameter, which is called the BBO, which is an evaluation of the performance of the envelope itself. So the passive behavior, if you want, of the building. And then we put the systems, and then we target an energy performance with some requirements like limited permeability. France was not, it was not usual in France to control the permeability of building. So we started with the voluntary label, and now it's in our regulation. And also, we put also some indication about summer comfort requirements, because of course it's very easy to limit the energy consumption if you stop cooling or heating. So the idea is to limit, in fact, the maximum number of days out of the comfort range. And as I said before, it's modulated with the type of building, the climatic zone and altitude, the mean surface of housing buildings, because you have to look at it also, because the same target for a large building or a small one has not the same consequence, and also to limit the greenhouse gas emission. So the main changes are that we have no more difference based on energy sources, because before in France we have different targets with different energy sources, so it disappeared completely. The requirement is expressed in absolute value and no more in comparison to a reference building, because in the previous regulation you had to define a reference building considering your location and so on, and you were comparing your real building to the reference one. So it disappeared, so it's an absolute evaluation. And our target now is the next regulation. We are planning it for 2020. So in order to prepare this, in fact, we are following the same scheme, in fact, and we will have the experience of the previous voluntary label, which was excessively successful. Last year in France, a high percentage, about more than 80% of the building licenses were asking for this label in the residential sector. And now we passed the new regulation, so the idea is to have the same policy. And we have already a new voluntary label already published in 2020, but this year, last year, at the end of the last year, excuse me, which is 20% more efficient, let's say, roughly speaking, for the building than the actual regulation. So it's 20% less consumption, roughly, 20% less permeability, but new items are arriving. Less information to the users, user behavior, I was talking about this morning, which is very influent on low energy building. On-site energy production evaluation, so it's not mandatory, but you have to evaluate the potential, and also evaluation of embodied energy in the project. And we have a new one this year, which is focusing on towards positive energy building. So we have a new label. In this label, it's exactly following the previous one. So you have the same target for the quality of the building itself, but you have, in the previous level, you had to evaluate the potential of using renewable energy. And now you have to evaluate your project in front of this potential use of renewables to see what is the gap between the use of renewable and the potential. And now we are waiting the new labels, because these two labels was proposed by the NGO. But now we are waiting for the official label accompanying the new regulation. They should be issued this year. We were waiting for these labels very soon, I hope, and they will take, roughly speaking, the same scheme, reinforce the performance, and evaluate the potential use of renewables. Thank you. That is the status in France right now.
Thank you to Francis, and then we proceed with Italy. Then Stefano, please, could you take the place and give your presentation? Thank you.
Thank you, Chairman. So let's have a look about what's going on in Italy. First of all, I will give you two pictures. One, the status, and the other part more related to the critical aspect about the implementation of this concept. One of the key aspects is related to the fact that in Italy the laws about this kind of implementation are regional law. So each region has to develop its own specific law related to the implementation of each decision at European level. So the process is quite difficult to be implemented we have this difficulty also in the implementation of the energy certification scheme, because each region has its own energy certification scheme. So the passage from European Union to the central government to the region is quite low. This is a big issue to deal with, and this is one of the key aspects. Okay, so what we have now we have the energy certification, not in all the region, but they say more or less the energy certification has been implemented. From the European directive in 2010, the transposition of the European directive was taken in Italy in the June of this year. So we are at the very beginning of this process. I don't want to enter too much why we live 3 years without having this transposition, but this is the status. And from June to now, we have the clarification of how we can transpose the national law that gives, let's say, the guideline to be respected according to the European directive at the regional level. As I said before, because as many of our regions are not yet able to fully implement the energy certification, are not yet fully able to implement all the topics related to this nearly zero energy building scheme. What is important in all of this activity is to point out 3 big topics to be developed that are already mentioned by Livio. One is the definition of the reference building. It's a big topic because, as Livio mentioned, one of the key aspects is to give, together with the energy performance, the economical aspect related to the energy performance. And to do this, we should analyze at the regional level, or at least at national level, what are so-called the reference building. We had a wide activity also with the Istanbul Technical University about this topic. And this is one aspect that is related to the fact that we have a statistical description of our building stock. It is not easy to have a statistical description of the performance of our building stock. Because if we want to have significant economical analysis, first of all, we have to have significant energy analysis. So this is a big challenge. If we have a good definition of the characteristic of the building stock, and we have also good and economical analysis toward the cost optimality, we can have this famous benchmark value or reference value in order to match both the economical and the energy aspects. Right now we have only region Lombardia, that is the region of Milan, that has started the process. They have a very ambitious process, I know from Livio. They would like to start very speedily the process in order also to speed out all the process in Italy. I would like just to show you a short of misunderstanding at the very beginning of this process. Because, for example, in Regione Piemonte, 2 years ago, they started to have a financial support to, let's say, high-performing building. As said Livio, sometimes you cannot be in the market with this very, very high-performing building because the construction cost is very high. So they started to have a financial support for this kind of building. And they associated the nearly zero energy building with passive houses. That it is completely another challenge. So I think that a clear definition of what is a nearly zero energy building and the approach has to be really clarified at national level. So you can say, okay, you did nothing in Italy, so you can end your presentation. But no, I want to go on, because I have 15 minutes. So And so I tried to summarize some big challenges that I think that are the big challenges that we have to face all around Europe and all around the Mediterranean country. We said about these two big issues, energy, economy. I put also architecture, because I think that this is one of the first aspects that also Francis mentioned this morning. I think we have to speak with architects in order to score the goal. We cannot speak without having on the table the architects, because the architectural and the composition of the building is one of the major aspects in order to reach this goal, with also an economical sustainability, because the simplification of the construction process is one of the key aspects to reduce the cost. I fully agree with Francis. This is why I put this arrow going to this optimality point, because I think that in order to be able to find out the optimality, we have to start a long process where the architects can understand our point of view. The other important point was related to this existing building. So the Francis called nearly zero retrofitted building. Yes. I fully agree. I mean that the challenge of the market is to deal with this kind of building, because in Italy the rate of construction of new building is very low. So what is our market is the retrofitted building, and so we have to find there the way to find out this point of minimum. And then, and this is the big challenge, to control the design, the construction, and the operation phase. Are we prepared? In Italy, no. We are not prepared to control all these aspects at the same time at the very beginning of the concept of the process. I think that all the subjects that are involved in the process has to be considered as subject that has to increase the knowledge step by step. Because sometimes we have perfect design, but we are not able, or the construction company is not yet able to transpose this design in a construction and then with a good operation. So I think that this is another important aspect, because if we are, take a look there, we always speak about global cost. The global cost, as we mentioned, is a synthesis of design cost, construction cost, operational cost, maintenance cost, and so on. So everything should be considered at the very first stage of the analysis. The other big challenge in Italy, we always like to think that the other countries are doing better than us. So we are copying all the activities and experiences from Germany and Scandinavian countries. That, that could be fine for the Alpine zone, but not for the Mediterranean countries. It's clear. I think that this tendency of copy and paste, that is also related to the fact that sometimes architects love this kind of architecture, but they do not know actually what is the technical energy part of those architecture, has to be deeply considered. We have a long tradition in construction of buildings. We have a long and important tradition in defining the way by which we can use our natural sources in Mediterranean country. We have to be proud to be Mediterranean, and we have to be proud to come back to our origins in terms of construction. I think this is a crucial passage, and it's important both from the building point of view, but also from the system point of view. Then I try to put four, in my opinion, of the big weak points that we have to think about in this new idea of nearly zero energy building. In Italy, we have the invasion of the super insulation. everywhere. It seems that if you don't put 20 centimeters of insulation everywhere, from Bolzano, that is in the Alpine zone, to Palermo, that is the very, very south zone, you cannot make a nearly zero energy building. It's not like this, because in the Mediterranean country, as we know very well, sometimes the big problem is to control the cooling load. And on the contrary, the tradition, in our tradition, the big challenge was the right use of the thermal mass. And we don't have any codes, any rules that defines a right regulation to use the thermal mass in the design. We have lots of code inserting the activity related to minimum thickness of the insulation, but nothing with respect to thermal mass. So we have to think about a lot about this. Then the solar control. I think that I always see these very nice highly glassed buildings that are nearly zero energy buildings, yes, but because they are in the north part of Europe. In our tradition, especially in the south part of the Mediterranean country, typically the windows are very, very little with high thermal mass. So why we have to copy this tendency in loving very, very light and glassed building. Then the other challenge, in Italy this is very, very important because we have no tradition about mechanical ventilation with heat recovery. The mechanical ventilation with this very low, in this building with this very low permeability is one of the key aspects. Because we have to think about that our tradition is to use natural ventilation. On the other side, we have the need to control the ventilation. I don't know, nobody in Italy wants to change and enter this new world, this new activity of mechanical ventilation, so we have a little bit also to be on the right side of the user and explain exactly what is mechanical ventilation and how to use mechanical ventilation. At the end, my experience. Now I am trying to build my new house. So I'm in the pot. And I'm trying